Hello students, in this video we will deal with second kind of a numerical based on RL series circuit. So let's read the numerical firstly. A coil connected across a 250 volt 50 Hz supply takes a current of 10 ampere at 0.8 power factor lag. What will be the power taken by the choke coil when connected across a 200 volt 25 Hz supply? Also calculate resistance and inductance of the coil. So look at this. The numerical statement is talking about some coil connected across some voltage source such as 250 volt 50 Hz. So and the power factor in such a case is 0.8 lagging. So we know that in case of series RL circuit only it is possible that it will be lagging power factor and its value will be somewhere between 0 to 1. Somewhere between 0 to 1. Higher than 0 and less than 1. So it is definitely, we are sure that this is a numerical based on series RL circuit. Now to understand it thoroughly and to understand what is to be done, we need to correlate this example with some real life experiment. So see, somebody is performing an experiment over here where a coil is taken and is connected across 250 volt 50 Hz single phase supply. And in such a case, reading of the ammeter, that is reading of the current through this coil, was measured and it was found to be 10 ampere. Also the power factor was noted and it was found to be 0.8. Now the person who performed this experiment wants us to find what will be the power taken when the same coil is connected across a different source. The source is different in value of voltage as well as in value of frequency. Look at this carefully. Second time when the same coil is getting connected across supply, the value of voltage is 200 volt and value of frequency is 25 Hz. Earlier it was 50 Hz and voltage was 250 volt. Now before we actually begin solving this numerical, one should understand what will be the effect of frequency on the coil. So see, coil actually represents series RL load. It means its resistive part and inductive part, will they be affected by the change in frequency or not? This is a question. So we should understand that resistance actually does not change with change in frequency of the supply, whereas inductive reactance changes with change in frequency of the supply. So if we know this, what I mean to say is value of XL will be different in both the cases. So keeping this in mind, we will try solving this numerical. So let's begin. We will firstly identify the given things. The given things are noted as voltage as 250 volt, frequency as 50 Hz in first case. So that is why I denoted it as V1 and frequency F1. Similarly in the first case, it is 10 ampere, that is the current flowing, and power factor at that point is 0.8. Now V2, when the experiment will be performed or when the calculations are to be done, are the voltages V2 is equal to 200 volt and frequency 25 Hz. We are supposed to find out what will be the power taken in second case, what will be the value of resistance in second case, what will be the value of inductance of the coil. So see, we shall begin solving this numerical. Firstly, we will find out impedance of the coil getting connected across the 250 volt 50 Hz supply. What I get is, it is 25 ohm. And how did I do it? It is Z1 is equal to V1 by I1. So 250 volt was the supply, 10 ampere was the current flowing. So impedance of the coil during the experiment must be 25 ohm. Okay. It also means that R1 can be found out by using a simple formula, R is equal to Z cos phi. So in this case I should write R1 is equal to Z1 cos phi. So I get resistive part in the impedance or resistive part of the coil is of 20 ohm and inductive reactance part is of 15 ohm. So if I use the formula XL1 is equal to 2 pi FL1 and rewrite it to obtain L1, what I get is XL1 upon 2 pi F1, and if I substitute value of XL1 obtained over here as 15 ohm and frequency in the first case as 50, what I get is 0.04774 Henry. So see, this is to be noted. What you did over here is you found out inductance of the coil. Now see, you have to remember this thing. Whenever an inductor is manufactured, its inductance is decided and ideally it never changes. Now this inductance will form different inductive reactances depending on the different values of frequencies. So keeping this in mind, I shall move further for the second case of voltage and frequency. So R2 will still remain, resistance will still remain 20 ohm when the coil is getting connected to second kind of the source, that is 200 volt 25 hertz. So instead of calling it R1, I am calling it now R2. Similarly, I will call XL as XL2 instead of XL1 in second case. So in second case, what you notice, I would find out the value in this fashion. So formula is 2 pi FL and I denoted frequency as F2. So see, this is F2, the changed frequency 25, and value of inductance never changes as I said. So value of inductance is kept as what was obtained earlier. And ultimately what I find is inductive reactance is a changed value. Inductive reactance has become 7.5 ohm than what it was earlier. Look at this, it was 15 ohm earlier. So inductive reactance value has become half when frequency has reduced to half the value. This was the thing to be noted in this numerical. And now inductive reactance if has changed, obviously the impedance will change. So impedance will be resistance and addition of the inductive reactance. So we write it as R plus JXL. So it is R2 plus JXL2, that will give us the new impedance offered. We can call it as Z2. So when I do this and convert it into polar form by using calculator, I should get 21.36 at an angle of 20.56 degree ohm. So if I move further to find power involved in the second case, I should write the formula V2 I2 cos phi 2. Active power is to be found. So P is equal to V2 I2 cos phi 2. Then V2, the value of voltage in second case is 200 volt. I2 was not found out earlier, but it can be found out over here itself. It can be written as V2 upon Z2. And secondly, the power factor will also change because power factor depends on the value of X. Because we know this phi 2 also has a formula tan inverse of XL by R. So XL has changed, so phi 2 will definitely change. So the changed value can be found out. Look at this, 200 is the voltage, V2 was 200 and Z2 was 21.36, and phi 2, if you find out, phi 2 is negative of this angle. Negative of this angle. This is the angle involved with Z2, when actually phi 2 will be angle involved with I2. And when we want to find I2, what we do is we divide V2 by Z2. V2 will have angle 0, Z2 is having angle 20.56. So when it is division, resultant angle will be 0 minus 20.56. So current will be accompanied with an angle of minus 20.56, and we know the angle which accompanies current is the power factor angle. That is why it is written minus 20.56 degree. If I substitute all these values and use calculator, what I get is 1753.38 watt. Look at this. Only by changing frequency of the supply, the same coil is consuming different power than the earlier case. The earlier case power can be found out in this fashion. You can do it on your own. The earlier case power will be 250 volt into 10 ampere into 0.8 V into I into cos phi, and this value will be different than this value. So only by changing the frequency of the supply, power that is getting consumed by the same coil changes, and it happens because inductive reactance changes with change in frequency. I hope you understood the meaning of this numerical and the way with which this should be solved. Thank you.